Pleasant day, everyone. We're the Group 8, and today we're here to discuss the continuity of a function. Here are the following objectives that will be tackled as we progress further. Number 1. Determine if the function f of x squared minus g of x squared is continuous at any point c. The second objective is determine if f of x plus g of x times h of x plus g of x is continuous at x is equal to c. And the third objective, determine whether f of x equals the square root of x is continuous at any point c. And the fourth objective, determine the points where g of x equals tan of x is not continuous. And lastly, create a piecewise function where f of x is continuous at any point x is equal to phi. Now that we know what our objective is, let us move on to the first question that will be explained by Wenceslao.
The objective of number 1 is let f of x and g of x be polynomial functions. Determine if the functions f of x squared minus g of x squared is continuous at any point c and explain why. But before we start, let's ask first what is a polynomial. A polynomial is an algebraic expression consisting of variables and coefficients combined using addition, subtraction, multiplication, and non-negative integer exponents. It can have one or more terms, each containing a variable raised to a non-negative integer exponent. For example, 3x squared plus 5x minus 2 is a polynomial with 3 terms. Here are the examples that I'm going to use. First is f of x is equal to 3x squared plus 5x minus 2. The second is g of x equals x cubed minus 4x squared plus 7x minus 9. First, we need to know that polynomial functions are continuous everywhere in their domain. This means that as you move along the x-axis from left to right, there are no sudden jumps or breaks in the graph. The graph of a polynomial function can be drawn without lifting your pen from the paper, unlike some other types of function that may have discontinuities. As you can see, the first example is polynomial, meaning it is continuous. If I put my finger on the line, it will keep on going non-stop. The same as the other example, it is also continuous. Now, what if the equation is f of x squared minus g of x squared? Meaning it's gonna be 3x squared plus 5x minus 3 squared minus x cubed 4 minus 4x squared plus 7x minus 9 squared. Is it still continuous? To determine if the polynomial functions f of x squared minus g of x squared is continuous, we need to consider the continuity of each component functions and the operations involved. The example functions I gave are both polynomial functions, and as I said earlier, polynomial functions are continuous everywhere. Number 2, the sum and difference of continuous functions are also continuous. And lastly, the square of a continuous function is continuous. This is the graph of the example functions I gave for f of x squared minus g of x squared. And as you can see, it is continuous. It is connected at the top, and when I drag my finger in the line, it does not stop. Since all the component functions are continuous and the operations involved, addition, subtraction, and squaring, preserve continuity, the function 3x squared plus 5x minus 3 squared minus x cubed minus 4x squared plus 7x minus 9 is continuous everywhere. So my final answer is f of x squared minus g of x squared is continuous everywhere at any point c as long as it's polynomial.
Suppose g of x is a polynomial function and h of x is a rational function that are both continuous at x equals to c. Determine if f of x equals g of x times h of x plus g of x is continuous at x equals to c. Let us have a quick overview. We all know that if polynomial functions are continuous for all real numbers, while a rational function is a ratio of polynomials where the polynomial in the denominator shouldn't be equal to 0. Now, in order to proceed to the given function, we must first understand that there are three conditions of the continuity, where the function will only be continuous if the conditions have been met or satisfied. The first condition, whereas the value of f of c should not be indeterminate, undefined, or does not exist, kailangan real number yung lalabas. The second condition, the limit of f of x as x approaches to c should not end up as does not exist or D and E. And lastly, the limit f of x and the value of f of c should be equal, otherwise it won't be continuous. What we have here is the example of the given function f of x equals g of x times h of x plus g of x, where ang g of x natin is equal to x squared, while ang h of x natin is equals to 1 over x. And we need to determine if continuous ba siya sa point na x equals to 2. We're going to apply the conditions of the continuity. Isa-substitute natin yung 2 sa f of x, so it will be 2 squared times 1 over 2 plus 2 squared. So, magiging 4 times 1 over 2 plus 4 siya. Kapag naman i-evaluate natin yan, yung 4, i-divide natin siya sa denominator, tapos ita-times sa 1, kaya naging 2. Tapos, i-add siya sa 4. Kaya ang magiging resulta is 6. Let's move on to the second condition, which is evaluating the limit of the function of f of x. Since nasatisfy natin yung first condition, pwede na tayo mag-proceed sa second condition, whereas evaluating the limit of the both side. Pero in these cases, pwede na tayo mag-direct substitution. Yung limit ng f of x natin, that is x squared times 1 over x plus x squared. So, if isa-solve natin yung limit ng f of x, ika-cancel out natin yung common factor ng x. So, it will be x na lang. Tapos, i-bring down natin yung x squared. So, it will be x plus x squared. After that, pwede natin i-substitute yung x is equals to 2. Kaya, it will be 2 plus 2 squared. Ang answer ay 6. Let us move on to the third condition of the continuity. We can say that the conditions have been met or satisfied since the value of f of c, which is the f of 2, equals to 6, and the limit of the function as x approaches to 2 is equals to 6 then. Therefore, the function f is continuous at x equals to 2.
Number 3 is to consider the function f of x equals square root of x. Is f of x continuous at any point c? The function f of x equals square root of x is a function that only considers and plot non-negative real numbers to their square root. It is defined only for x greater than or equal to 0, which means it's only applicable to non-negative values of x. It's crucial to emphasize that the function f of x equals square root of x is continuous only for x greater than or equal to 0, as it's defined only for non-negative real numbers. It's not continuous for x less than to 0. As the root of a negative number is not a real number, taking square root of a negative number will result in a complex number, which is beyond the scope of our real numbers. At x equals 0, the square root function f of x equals square root of x satisfy all three conditions of continuity. The first condition is if f of 0 equals square root of 0 is equal to 0, so the function value is defined at x equal to 0. Second condition is the continuity as x approaches to 0 from the right of x of the square root of x exists and equals to 0. And the last condition is since f of 0 equals 0 and the limit of x approaches to 0 from the right equals 0, the limit of f of x as x approaches to 0 from the right also equals 0, satisfying the condition of continuity. Therefore, we can conclude that the function f of x equals the square root of x is continuous only for x greater than or equal to 0, and it's not continuous for x less than to 0.
So I given a task in number 4 to determine the points where g of x is equal tan of x is not continuous. So the step 1 is to determine points where g of x is equal tan of x is not continuous. You need to identify the points where the function is not defined or where it exhibits vertical asymptotes. So what is undefined points? So undefined points, the tangent function is undefined wherever the cosine of tan of x is equal sine of x all over cosine x. So g of x is undefined at points where cosine x is equal 0. What is vertical asymptotes? Vertical asymptotes occur where the function approaches positive or negative infinity in the case of tan of x. Vertical asymptotes occur where cosine x is equal 0, but sine of x is not 0. These points coincide with undefined points x is equal pi over 2 or x is equal negative pi over 2. So here's the example from the Desmos. So I use the example y is equal tan of x to determine the graph. So as you can see in this example is the following example is equal to tan of x. So first example is negative 4 pi 0, negative pi 0, 4 pi 0, 5 pi 0, negative 3 pi 0, negative 2 pi 0, pi 0, 3 pi 0, 6 pi 0. So this example is discontinuous. So the conclusion is therefore g of x is equal tan of x is not continuous.
Let's move on to our last objective, which is we need to create a piecewise function where f of x is continuous at any point x equals pi. We will need the conditions of the continuity on the created piecewise function to determine whether it is continuous or not. At the first condition, we're going to substitute the pi to the f of x. The function of f of pi equals to 2 pi minus pi, which will have as a result of pi. Since the first condition has been satisfied, let's move on to the second condition, which is evaluating the limit of the both sides. The left side of our limit is f of x equals pi as x approaches to pi. On the right side of the limit, we have 2x minus pi, which means 2 pi minus pi equals to pi. We can conclude that the value of f of pi is equal to the limit of f of x as x approaches to pi. Therefore, the function f is continuous at x equals pi. Let's proceed to the next given example. Whereas f of x equals sine 2x if x is less than pi, and 2x times sine x over x if x is greater or equal than pi. On the first condition, we're going to use the second piecewise function since our x is equals to pi. We're going to substitute pi at the value of f of c, which will be 2 pi times sin pi over pi. We're going to cancel out the common factor pi, so ang matitira na lang is 2 sin pi. And ang magiging answer natin sa value ng f of pi will be 0. At the second condition, we're going to evaluate the both sides. So, on the left side of our limit, we have f of x equals sine 2x as x approaches to pi. And as we calculate it on the calculator, the answer will be 0. While on the limit of the right side, we have 2x times sine x over x. Ang answer niya is 0 rin. Now, let's move on to the third condition. As we can see that the value of f of phi is equals to 0 and the limit of f of x as x approaches to the pi is equals to 0. Therefore, the function f is continuous at x equals to phi. Once again, this is the group 8 reporting the video. Thank you for listening.